Good morning, students. In the previous class, we practiced lines parallel to both HP and VP and perpendicular to any one of the plane. Now, we are going to practicing when the line is inclined to one plane. So, we know that when the line is inclined to one plane, in one view we need to draw the image with the true length and true angle. In opposite view, we need to draw the image is a line with parallel to the XY line, but it is a reduced length. So now let us start the first problem. So the original length of the line is 75 mm long. The original length is 75 mm long. That is what we call true length of the line is 75. And the first problem is now he is given clearly the line is inclined at 45 degrees to VP. So we know that always the angle with HP, always the logic is very simple. So we need to mark the angle with HP. That is whenever the object making an angle with HP, that angle we can observe in the front view only. Whereas with angle with VP, we can observe it in the top view. So hence here in this case, since the line is inclined to VP means in the top view you will get the true length and true angle, whereas in the front view you will get the reduced length and parallel to x length. That means for the first condition, this is the expected solution. This is the expected solution. So let us mark here the true length of the line is here the length of the line is given as this length is the true length of the line, the top view 75 with the true angle. This angle is with VP is 45 degrees. This angle is 45 degrees. Now, now the question itself is given clearly 45 degrees to VP, and in the VP the line is in the HP. The line is in the HP means both points A and B are in the HP, which means that we know that HP distance can be marked in the front view. So in the front view, the in the HP means the front view distance is 0. That means this distance will be 0. This distance will be 0. And whereas one of its end is in the VP. So one end, not line is in the VP. It is a one end because you take an A point and B point. These are the both ends of the line. So you can take the any one end is on VP. So is on VP means we know that the distance from VP we are marking in the top view. Hence, in the VP means the distance from VP is 0. That is the top view distance is 0 because now we are considering the nearest end is A point here. This A point is in front of VP is the distance is 0. So now this true length is given. The original angle is also given 45 degrees and above HP in front of VP distance are given 0 0. Just you can able to draw the solution because we got all the data. So now see how to draw the solution here. Draw the XY line here. So first of all, you know that by default the lines will be in the first quadrant, that is front view is above XY line, top is below XY line. So here in the first condition, the A dash point will be 0 distance because the line is on the HP. Because the line is on the HP means the distance from HP is 0. That is front view distance is 0. That is the A dash point will lies here on the XY line. Whereas the top view, because one of its end is in the VP means the VP distance is 0 for one of its end. So the nearest end I was taken here A, this distance will be 0. So this point again will become here A. Now in the top view, we know that because the line is inclined to VP, that angle we can get in the top view. Hence the angle with VP we can observe in the top view with the true length and true angle. That is draw a line with 75 length with 75 mm length with the angle is this angle is 45 degrees. So this point will become here top view, that is the B point. This length will be the 75. Now you can project this line B point to here. So this point will become here because this distance is 0 means here B dash also on the XY line. So this is a B dash point. Now join A dash B dash line. This is a reducer length. So this is the reducer length. This is the true length. For explanation purpose, I am writing. There is no need to write here. AB is the true length. So this is the solution for the first case. Now the next case is clearly given the line is inclined to HP. So line is inclined to HP means the angle with HP we need to mark in the front view. That means whenever the line is inclined to HP means in the front view we need to draw the true length and true angle, and in the top view we need to draw the reducer length but parallel to the XY line. So that means this is a possible condition, possible solution for the second one, because the line is inclined to HP. This is the line condition inclined to HP. So the data will be like this. The original length of the line is 75 mm. Its one end is 25 mm. Above it means above HP. So that means HP distance is 20 means A dash is 20, and it is parallel to the VP and 30 mm in front of VP. VP distance is 30 means VP distance we have to mark in the top view. Distance will be 30. Now this angle will be horizontal plane angle will be 30 degrees. So we know the every data. Now just draw the solution here. So first of all draw the A dash point above XY line with a distance of 20 mm because it is a 20 mm above the HP. Similarly draw the top view, that is a small a, that is in front of VP is 30. So after that, because here the line is inclined to HP means the angle we can get in the front view. Hence in the front view, just before going to draw the line with the true length and true angle, at A dash, you first of all draw a small line parallel to the XY line like this, because we need to measure the angle here. We need to show the angle here. From A dash, you draw the this line. From A dash, you can draw the line with the respective angle. What is this angle here? 30 degrees, and this length will be the 75. This point will be B dash. Now since the top view is a reduced length, so we doesn't know what is the length of this reduced length. First of all, draw a line in the top view parallel to XY, which we doesn't know the length. Just draw the parallel line. Approximately it will be exactly coincide with B dash. Now draw the projector line from B dash perpendicular to XY till it meets this parallel line. So where it exactly meets in the top view, this point will becomes here B, and this is the reducer length. We have to dark this one. So this is the finally the top view. This is the finally the top view. That is nothing but this length will be the reducer length. So this is the solution for the second case. Now the last condition. Once again the line is inclined to VP. Again line is inclined to VP means the possible solution will be this one. So in this case, so we know that because the line is inclined to VP means that angle we can get in the top view. So the original length is 75 here, and angle is with VP is 60 degrees. Here it is 60 degrees, and here one of its end is 15 mm in front of it. That means from VP. So distance from VP is 15 means this distance is 15. VP distance we have to mark in the top, and at the same time parallel to and 25 mm above the HP. From HP distance it is 25. So HP distance we have to mark in the front view, that is this distance will be 25 mm from HP, that means this distance will be 25. Okay, now draw the solution. First of all locate the A dash point at a distance of 25. Now top view A point the distance of 15. So we marked the one end of the line. Now draw the final solution. Because the line is inclined with means this angle we can get in the top view. Angle with VP we can get in the top view. Hence in the top view you draw the with original length with original angle is this angle is from this line this angle is 60 degrees. Then you can get the this point B. Now draw the projections. So we know that in the front view we can get the image is a parallel, but we doesn't know the reduced length here. Just draw the parallel lightly. And because V dash lies on the same line, draw the projector from B. It will meets the parallel somewhere else here. Exactly this point will become B dash. So draw with the projector line. Draw the projector line where it meets exactly this parallel line. This point will become B dash. So this is the final front view. That is what we call reduced length in the front view. This must be darkened. Similarly, in the top view, this must be darkened. So this is a expected solution for the third quadrant. But remember here I am showing the distances 75, 25, 15, 20, 30 all just I am writing here with numbers only. But we have to show in the dimension format as explained in the previous case. Like this I need to show these distances. So I need to show like this. So if this A dash is let us say 25 mm, draw this extension line, draw this extension line, draw the line and give the gap here middle, fill the arrow marks here, fill the arrow marks here and write the value here, its respective value at the middle. Like this we have to mark here itself dimensioning. That procedure we have to follow. But for explanation purpose, I'm just writing the values only here. But we have to follow the method of dimensioning. Okay. So this is a case lines inclined to one plane in the simple position. Thank you.